All right, here we're going to go ahead and work out the problems for surface area just so you have them to look at. I already did the first one for you, but let's go ahead and try the rest of these. First off, what is the surface area of a cube whose sides are 8 feet? And so if we have a cube, right, cube, just like this, and every one of the sides is 8 feet, 8 feet, 8 feet, the length, the width, the height, then what we need to worry about is the idea that each one of our surfaces is just a square, and they are all the same square, and there are 6 of them. There's the front one and the back one, right? There's this side over here, there's this side over here, and then there's the top one up there and the bottom one down there. So there are 6 sides, 6 faces to a cube, which means we can do surface area is equal to 6 times the area of one of the faces, and each face is 8 feet squared. So if we look back at our equation for this, which was on this page, it's 6 times the length of a side squared, and that's it right there. So we can go ahead and do that. And 8 times 8 is 64, and 64 times 6 is 384. And then this is going to be feet squared, since we have feet and squared, so feet times feet. And there we go. That should be our answer. And if we check it, 384 square feet. So that's good. That's what the feet squared is. So let's go on back here. Next, we had this one that I talked about in the last video where I said convert it to feet first. And so we have a box that measures 12 by 36 by 60 inches, but we want the answer in square feet. So the first thing I did was make this 12 inches 1 foot. 36 divided by 12 is 3, so that's 3 feet. And 60 divided by 12 is 5 feet. And so that means we have a box that's 1 by 3 by 5. Pretty big box. 1 foot, 1 by 3 by 5, like that. And we need to find its surface area. And so the surface area is going to be twice the area of the faces, because this face, like for example, this front face is there, and it's also back here. It's that face as well. So we just double the area of those 2 faces, and those 2 faces are 1 by 3. So it's 2 times 1 times 3. I'm sorry, I should have put feet on those. 2 by 1 foot by 3 feet. And then the next pair of faces we can do would be 2 times 3 feet by 5 feet. That's this one over here, and then this one back over there. That's those 2 faces. And then the final pair of faces we can do is the top and then the bottom, right? The top and bottom faces, which are, oh wait, so that's this one, I'm sorry. That's the top and bottom face. That's the top and bottom, 3 by 5, like that. That's the top and bottom, my mistake. And then now we need to do the 2 sides, and this has a height of 1, so it's actually, this side is 5 by 1 and 5 by 1. That's the 2 side faces. So 5 by 1. 5 feet times 1 foot. And we go through and do this. This is 2 times 1 times 3. That's 6 in feet squared, because it's a foot times a foot. Plus 2 times 3 is 6. 6 times 5 is 30 feet, and again squared, because a foot times a foot. And then here we have 2 times 5 times 1, which is just 10. And again, a foot times a foot gives us a foot squared. So now each one of these terms is foot squared, foot squared, foot squared. So we can add those all up and just carry the foot squared along, because we're not multiplying them together, we're adding them. They're all the same, so we can add them. And then we just carry them along. We don't make them like feet to the 6th or anything like that. So we just need 6 plus 3 plus 10. So that's going to be 19 square feet, or 19 feet squared. And so let's double check to make sure we have that one. That's number 3, and I seem to be off there. 1 times 3 I did this one earlier, and I think I did get that 46. So what did I do wrong here? 5 times 1 is 5, plus 2 is 10. 2 times 3 is 6, that's 30. Oh, well, because I added 3, not 30. Oops. This is 6 plus 30 plus 10. 6 plus 30 is 36, plus 10 is 46 feet squared. So there we go. Sorry, I did 6 plus 3 plus 10, and it's 6 plus 30. It's a 30 there. All right, so there we go, 46 feet squared. Now let's find the surface area of these ones. So for this, we need to find the surface area of the top and the bottom. So we're going to have surface area equals 2, and we're going to have 2 times the area of the base, that's pi r squared, plus we need the outer sleeve part, which, if you can remember, we can roll that out flat so it's like a rectangle, and the height of the rectangle is going to be the height of that, and then the length of the rectangle is the circumference, which is 2 pi r. And if you go back to our equations for this, that's what we end up with. 2 pi r squared is the area of the top and the bottom, and then 2 pi r is the circumference times the height for the area of the outer sleeve. So 2 pi r squared plus 2 pi r h. And so this will give us 2 pi times 5 centimeters squared plus 2 pi times 5 centimeters times our height of 13 centimeters. Okay? And so 5 times 5 is 25, and 25 times 2 is 50. And so we get 50 times pi, and then that's 157.08, so about 157.08. Leave it in my calculator, and I'm going to do plus, and I'll do 2 times pi times 5 times 13 to get that other sleeve on there, and I get 565.487, so 0.49. And this will be centimeters squared. This will be centimeters squared because of the 2 centimeters there, and they add up to be centimeters squared. So that should be our answer there. And we'll check it, 565.49, and there we go. We have the answer. Oh, we got that one right too when we fixed it to 30. So there's that one. So next I'm going to move down here a little bit. So this is the surface area of a cone. And for this one, what we do is look back right here. It's this equation right there, and this is kind of a lengthy one, so I'm going to go ahead and just copy it real quick and paste it over here just so we have it, and we can start right from there. So that's what we need to start plugging in. We have the radius right there, and we have the height right there. So that's what we need in order to do this. So let's start plugging this in. So this is pi times the radius of 6 centimeters squared. That's a 6. Plus pi r. Oops, not r. Pi. Plus pi times the radius of 6 centimeters times the square root of 6 centimeters squared is going to be 36 centimeters squared, plus the height squared is 100. It's 10 squared. 100 centimeters squared. And so then if we go through and start putting this into our calculator, we can do pi times 6 squared is pi times 36 plus, and we'll do pi times 6 times the square root of 136. All right, and this gives us a 332.919, so 0.92. Here we have centimeters that gets squared, so centimeters squared. Here we have centimeters times, well, inside we have centimeters squared plus centimeters squared, that's a centimeter squared. And then we take the square root of it. So this overall is just a centimeter, and a centimeter times a centimeter is a centimeter squared. And then centimeter squared plus centimeter squared is just centimeters squared. So that should be our answer. We'll double check it, 332.92. There we go, we're good. And so the last one we have to do for these surface areas is the surface area of this sphere. And the surface area of the sphere is 4 pi r squared. If you go back over here, we had it right there, 4 pi r squared. And so, oops, switching pages, did I come over here? And so now we just need to plug that in. 4 times pi times 6 millimeters squared. And so 6 squared is 36 times 4 and times pi on our calculators gives us 452.389, which becomes 0.39, and then millimeters squared. And then that should be our answer, 452.39, 452.39. Oops, which is what we have there, 452.39. So we checked that one off. We got it right. All right, so there's all of those answered. I hope that helps you. If you're having trouble with any of them, hopefully that clears it up. All right, thanks.